Hello and welcome back. We are continuing our discussion on advanced testing by moving forward with writing integration and acceptance tests. In previous weeks, we've already gone over unit testing, how we do it, what they're good for, and our first video was kind of just a quick overview. So now let's dig a little bit deeper into these other types of tests. So what actually makes a test an integration test? Well, an integration test will verify that two or more real components, so actual functional components in your code, are correctly interacting with each other in a real runtime environment. So this should be testing multiple modules together, the service talking to the repository or a controller talking to a service, and it's going to use real dependencies, not mocks or stubs. Right, we're not going to mock out the component that we're testing. Previously in a unit test, we did want to mock out the not testing units because we were testing a single unit. But here the entire point is to be testing that integration, testing that connection between the two, so we don't want to be mocking any of those pieces. It doesn't mean that other external pieces can't be mocked. It's possible that we are still mocking other pieces, but we really want to make sure that we know what it is we're trying to test and that those two pieces are, or more potentially, are actually talking to each other as if they were the real life code. So these will often run against a test database or file system or even some kind of HTTP endpoint. Now, just because we want to actually connect to our real component doesn't mean we have to use like our production database. So we can test our program using a test database with test tables and test data, and it's still considered an integration test because we're connecting to the real database service as opposed to just like a stub that's returning sort of whatever data. But that doesn't mean we're actually like using production like data or like real customer data. So perhaps we're testing our order service, saving to a real database, right? Again, we want to save to a real database, but it can just be its own copy of it, so like a test version. A login controller calling real validation logic and authorization services. So actually making sure that we are getting real logic flowing through. We're testing that we actually get the validators running and they're testing what we're expecting. Or a file parser that would read an actual file and produce results. So maybe we have some kind of file parser and we pass in some test files and then we know what we're expecting to have come out of it. So when we want to have some good database integration tests, as most of us will be doing that in this class, we really have to consider what our arrange, act, and assert are, right? So our arrange or our setup is going to most likely involve creating a test database in memory and then inserting or preparing some sample data. Depending on the complexity of your tests, you might need to do this for every single integration test. You might be able to sort of tie into using transactions so that you're not constantly creating a new database, but you're not constantly dealing with the like deletion and recreation of data all the time either. It really just depends on what you're trying to test and how you're setting it up. Once we've done that, we need to actually do our action. So maybe it's like saving a recipe or finding an ID, whatever it might be. We want to call our actual service methods that are going to connect to our real database. Not a mock, real persistence logic will run, and then we can go and we can assert it. When we're doing these assertions, we can do it in a few different ways. We can confirm that the record is saved and retrieved like from the database or deleted from the database as we expect, right? We can actually check in the database and check the contents of the database. We can do this by connecting to it directly or possibly depending on what kind of behavior we're testing. Maybe this is more of checking like what certain objects are holding or what certain controllers can get access to after certain runs have occurred. It really just kind of depends what it is you're trying to test. So here's just kind of an example of what you might do. We can see here that we have like an H2 database and this is running before each. This before each tab means it will run before each test. So we set our data source, we set our recipe repository and our service recipe before each test. So we're always starting with a clean new database. This start function maybe makes the connection and seeds data, or maybe it's just making like opening up the connection to the H2 database. It just kind of depends. We're making sure that we're passing that into a new repo each time, and our repo is being set within the service each time. Always brand new, totally fresh. This is within a test file. Then in the actual test, save recipe correctly, we have our arrange where we're making our recipe. We have all of the data we want to include in it. And then we have our save as well. So we can call our recipe service to save it. And these are real repositories and real data sources. So it should run through the recipe service however it's set up, as if it was in production. Once we've done that, we can go ahead and grab the saved recipe, find it by the name that we previously passed in. We can see right there. So we can call recipe service, find by name, and we can make sure that we got that one back. It didn't return like a null or something that didn't exist. We can make sure that one of the ingredients is cheese, and we can do a lot better of a job of saving the recipe correctly and testing for it here. We also could be using this data source variable directly, and rather than making a new recipe and calling find by name, we could just go directly to the data source, write a command, like write a SQL statement or whatever, some kind of executable command to grab this information directly from the database and make sure that .save did indeed put it in the database. So that's always a really nice direct way to make those checks. Now for acceptance tests. So an acceptance test is slightly different from an end-to-end or system test. It really depends on your definition and how people describe it to you. But with what we're going to work with, an acceptance test is basically us asking, does the system do what the user is expecting? A test that verifies whether a user behaves as intended based on the user stories from the beginning, right? The requirements and scenarios we set up. That is what an acceptance test is actually verifying. So they are focused on outcome, not implementation. We just want to make sure, for example, that if I log in with the right username and the right password, that I successfully get in. You'll notice that nowhere in there do I talk about authentication or database management or encryption or any of those things. This is a very, very high level test. If I provide the right information, then I can successfully log in, right? So often these tests are end-to-end, meaning from input to output. We inputted the name and password, we output success, you're logged in, right? And these are often written from the user's perspective. Given a user name and password, when I log in, then it is successful. Nothing about authentication appropriately, nothing about verification, none of that, right? All of those things come in at lower levels where we can test those nitty-gritty details. Now, it is possible for us to use some tools that exist in order to write acceptance tests and to use them. We've got Cucumber, JBehave, or even just some like plain code and testing frameworks. It really just sort of depends on what it is you're trying to set up and trying to do, but options do exist out there when you're trying to run these tests. Because these are so high level, often acceptance tests are run manually as well, so you'll have like a quality assurance person who's in charge of this, and their job would be to run through the acceptance test scenarios and ensure that the piece of implementation, the feature, the user story that's being tested is meeting those success criteria. Pardon me. This can be automated in Agile or continuous integration deployment pipelines. And as much as possible in those scenarios, we are, of course, trying to automate parts of this life cycle. So, for example, as a user, I want to save a recipe so that I can view it later. This will simulate user behavior across the full stack, right? As a user, I want to save a recipe so I can view it later. So this means we need to make sure that we can save the recipe, it goes through the controller, the service, the database, and then I also want to make sure that I can view it later. So that would be us actually going to get the recipe from the database as well. So this acceptance test is testing the whole story, not just the save piece, not just the view something in the database piece, but all together. Given a recipe I want to save, when I go to view it, then I can, right? Given when then. So we can see that this will do exactly that. We're going to test that we're saving a recipe through the save function. Here it's called submit recipe. Then we try to get the recipe right here so that we can guarantee that we can view it later. And is it there? All right, when it comes to actually setting up our test files, you've already done some, but maybe you've got a little bit of technical debt you're now going to need to deal with, because there are some naming and syntax conventions, especially in Java, that we typically will use. Really what it comes down to is, depending on where you work in the future or within your group, what did you decide on? What does the team decide on, and making sure we stick with it. So there's very common usage in unit and integration tests, so there's code-based syntax that we need to follow. They pretty much always will start with the word test. If they're like a JUnit 4 or 5 test or a Python test, that's pretty common verbiage for methods. like test user can save and retrieve recipe, or test throws error when username is empty. It's very clear from the name what feature or behavior is being tested, right? We can see that we are testing that the user can save and retrieve a recipe, or that when the username is empty, we want to throw an error. Doing this is important because a lot of our IDEs actually do rely on these names being what it's expecting. So it might be expecting it to be starting with the word test. So that's part of why we sort of talk about setting up a standard. It does help test runners auto-detect tests. It doesn't mean it can't detect tests with different conventions, but it might mean setting stuff up more manually and doing some more configuration that maybe you just don't want to deal with. And we should always, of course, as always, try to avoid vague names like test1 or check stuff or validate all. Those aren't really descriptive enough. A pretty common sort of form when it comes to writing your test methods is to say test and then put the condition, then an underscore, and then you can put when with the trigger that you're expecting to be pulling effectively in our test, underscore, then your expected outcome, and then that is what you're going to actually be asserting for in your test body. So there's some other tools and syntaxes and conventions that exist out there. So for example, there's behavior-driven, or known as Gherkin syntax, and there are some tools that do use this, so Cucumber and SpecFlow, and also some workplaces like to use this because it is pretty human readable. It's very, very common to sort of see this set up in acceptance tests, in UI level tests, things that would need to be more human readable because there's a higher chance a human is interacting. So for example, we have the save recipes feature, and the scenario we're working with is that a user does save a valid recipe. It should work. So it's given when then, just as we said, given the user is on the new recipe page, when they submit chili with appropriate ingredients, then the recipe should appear in their recipe list. This gives us enough information to start either automating this test or just running it by hand, right? So this sort of syntax and standard is really great for acceptance tests when they're tied to user stories. As a user, I want to be able to save my favorite recipes. That's the user story, and this is us being able to test for that user story, because this is also really easily reviewed by non-developers. So a reminder that in the real world, not everybody on your team may be a developer, may be super tech savvy. They're probably technically proficient, but they're not developers. And so we want to make sure that we are communicating the expectations in a way that sort of work for everybody on our team. We can also see that these are very focused on behavior. Like we said, behavior-driven development, BDD. So these are focused on behavior. They're not focused on code structure, what methods we pass through, what gets checked before other things. A common issue with like validating is, oh, well, do we validate it for all 5 conditions, or do we stop when we hit an invalid condition? None of that matters when we're talking about acceptance tests, and specifically when we're dealing with behavior-driven development or like the Gherkin syntax. It really wouldn't work in those scenarios. We are focused on behavior. Now, when it comes to actually organizing our project and organizing larger tests, we really want to make sure that we're organizing our test files to mirror our main code structure. So what you'll see happening here is we have inside source, main, Java, we have our recipe, and then inside recipe, we have recipe service. You'll see that we want to group by feature and module, not by not type of test. It's also possible that we would have like main Java service or main Java logic. Depends on what you name your packages, and that's okay. And then over here, we can have underneath that same source folder, we'd have a test instead of main, Java, because it's there as well. And then whatever the name of the package is at this level, maybe it's your layers like UI, logic, persistence, maybe it's by feature, maybe it's more levels deep. It really depends, right? We want to, at that point, mirror that as well. If this is called recipe service, this is the recipe service test. You can use consistent naming here. Perhaps you're using the user service test or the user integration test. Just sort of depends what we're doing, a user unit test even. It really just depends on how you and your team intend on structuring this. But the key is being consistent, picking something that you can standardize for all of your team members, for the whole development team. So we're going to combine our related tests into a suite to run them together as much as we can. And this is very useful for things like smoke tests before deployment, so just doing our once over before we actually release and deploy our code. For regression test packs, so actually making sure that things work before we make any big changes to it, and then when changes come in, we can run our regression again and make sure we didn't break anything. And making sure that we're only really grouping and running together, we're running only fast unit tests in our continuous integration. So you may have unit and integration and acceptance tests, but this grouping will allow us to ensure that the things that we want running in continuous integration are grouped together versus things that maybe are more manual or only on deployment or whatever it might be. We talk a lot more about that in software engineering too, if you get a chance to take that course at some point. Now, I'd already shown the before each when we were talking about setting up our database, like our test database and our integration test, but it's worth noting there's like a before each and an after each, which will basically run before and after every single test method that you write. And then there's the before all and the after all, which is really only for that expensive shared setup at the very beginning and very end. So maybe before all, you connect your database, and after all, you disconnect it. Before each, you start a transaction, and after each, you're going to roll back each transaction. So then your database is always in the state that you need it to be in. This allows us to keep our tests independent from each other and means that we can run them in any order. One test data should not affect another test data. And it allows us to clean up any artifacts that we're leaving behind, right? Like any files, connections, temporary data, things that we want to clear out of the system so that we're not leaving stuff behind once our test suite is finished running. We don't want to keep creating a bunch of temp files if they can just be deleted when we're done running our test suite. So I'd like you to take a second to go and look in your projects and pick a feature that was finished this week. It says a feature you finished this week, but ultimately you probably didn't finish a feature all by yourself. Maybe you did, that's awesome, but my guess is you're thinking more like at a higher level, more collectively. Take a feature that was finished this week in your project and then try to write a skeleton acceptance test for it. In fact, if each person in your group wrote an acceptance test for one of the user stories that fell under that feature, you would be like done this part of the project. You'd have to implement it, of course, but I just mean if each of you took over one of the user stories, writing the acceptance test for that user story, actually like writing it out nicely and then implementing it, you'd be done your acceptance tests. So take a minute to give that a shot. Hopefully you'll find that it's helpful to sort of see it in your own project and be able to walk through that flow. Thanks for joining me on this deeper dive into integration tests and acceptance tests, and I will see you in the next video. Bye.